All right, what about compositions of functions? You may remember composition of functions. It's where you put one function inside another function. We learned about that back in college algebra. So the way composition of functions interacts with continuity is like this. If we're going to be making a composition f of g of x, like that, if the inner function g of x is continuous at some number c, right? And then if f of x is continuous at not c, but g of c, right? The output that g will be giving, the one that will become the input for f, then that composition will be continuous at c as well. So just to draw a picture of how this works, if you took my college algebra, you remember me drawing this type of picture all the time, talking about composition of functions. Take your c number and stick it in the g function, and then out of that you're going to get g of c. And then that number, that output, is going to become the input for the next one, which is called f. And then what you're going to get out of there is f of g of c. Okay, so what we're saying is g needs to be continuous at c, and then f needs to be continuous at g of c. Then the composition is continuous at c, because the composition is what you get if you kind of take these two function machines and you stick them together. This will be called f composed with g, and what you get out the other side is f composed with g of c, which is the same as f of g of c. So that's what's required in order for a function composition to be continuous. Let's do an example. Let's look at h of x equals the square root of sine of x. So in this case, we have h is f of g of x, and our g of x is the inner function sine, and our f of x, the outer function, is the square root 1, right? So I can write that as square root of x, like that. So let's ask, is h continuous at x equals pi over 2? Well, our inner function, sine of x, is that continuous at pi over 2? Sure it is. Sine of x is actually continuous at every point in its domain, and its domain is all real numbers. So sine of x is continuous, and sine of pi over 2 equals, anyone remember? Pi over 2, I'll draw a little circle. Pi over 2 is 90 degrees, which is up here. That's the point 0, 1. And the sine function will output the y coordinate, which is 1. So sine of pi over 2 is 1 for that one there. And then let's ask now, is the outer function f, square root of x, is that continuous at 1? Sure it is. 1 is in its domain. It's a radical function, and those things are continuous at every point in their domain. So square root of x is continuous at 1. So the answer is yes. H of x is continuous at pi over 2. But if we ask, is h of x continuous at x equals 3 pi over 2? Well, sine of x is continuous still. That's fine. Put a line between these here. Sine of x is still continuous. And in particular, sine of 3 pi over 2 equals, well, 3 pi over 2 would be 270 degrees down there. That's over here. 0, negative 1. So we're talking about negative 1. And then you can probably see what the problem is. Square root of x is not continuous at negative 1, right? So the answer here, this time, would be no. Right? Because negative 1 is not in the domain of square root of x. It's not continuous there. So that's kind of how you can analyze a composition of functions to determine if it's continuous at a particular point. Yeah, that's about it.